Hi students, so welcome you all again. Today I am going to continue with your vectors chapter. So in the vectors chapter from the previous class we have solved 14 problems. In the previous class we have solved 14 problems. Now we shall continue with the 15th problem. Clear? So these are the observations we have seen in the previous class, and we also seen the observation 3 and 4 in the previous class. We have solved example 13 with the solution. We have solved example 14 and this is the solution. Now we shall go for the example 15. Clear? So in the example 15, clearly they have given in the example 15 clearly they have given vector A and vector B. See here, clearly they have given vector A. If vector A equal to 5 I cap minus j cap minus 3 k cap and vector B equal to I cap plus 3 j cap minus 5 k cap, then show that the vectors vector A plus B and vector A minus B are perpendicular. Okay. So by using vector A and vector B, first we have to find the sum of two vectors. Next we have to find the difference of two vectors. After that we should check the scalar product. If the scalar product is equal to 0, then it is understood that vector A plus B and vector A minus B are perpendicular to each other. Clear? So for that reason, what we have to do, first we shall solve vector A plus B. So see here, vector A plus B is equal to, we have to take the sum of vector A and vector B, so that 5 I cap plus I cap is 6 I cap minus j cap plus of plus means it is plus. So minus j cap plus 3 j cap is plus 2 j cap minus 3 k cap minus 5 k cap is minus 8 k cap. This is vector A plus vector B. So next we shall solve vector A minus vector B. See this vector A minus vector B. Okay. See here you have 5 I cap minus I cap. So 5 I cap minus I cap will be equal to 4 I cap. See this thing. Okay. Next, minus j cap. Minus into plus is what? Minus. So that is minus j cap. Minus into plus is minus. So minus 3 j cap gives you minus 4 j cap. See this? Clear? Next, minus 3 k cap. Minus of minus is what? Plus. So that is minus 3 k cap plus 5 k cap will give you plus 2 k cap. You can see here. Okay. So this is vector A minus vector B. So after that we have to solve the scalar product between vector A plus vector B and vector A minus vector B. So you have to remember, whenever you make scalar product of two vectors, take vector v1 and vector v2. If I make scalar product, it will be a1 dot a2 plus b1 into b2 plus c1 into c2. So here a1, b1, c1 are the coefficient of I cap plus j cap plus k cap of vector v1. Okay. And what about a2, b2, c2? They are coefficients of I cap, j cap and k cap of vector v2. Clear? So we have to take coefficient of vector I cap from v1, we have to take coefficient of I cap from V2, we have to multiply. Okay, so after multiplying, you are going to take the sum of this and you have to simplify. Okay, so here A1 is 6, A2 is 5. So A1 into A2, 6 into 5 is going to be, sorry, A1 is 6, A2 is 4. Okay, so 6 into 4 will be 24. Next, B1 will be 2, B2 will be minus 4. 2 into minus 4 will be minus 8. This 6 into 4 will be 24. Minus 8 into plus 2 will be minus 16. So if you take sum of this, you simplify this, you are going to get equal to 0. Clear? So therefore, we can say that scalar product is 0. So this implies vector A plus vector B is perpendicular to vector A minus vector B. Are you cleared? Okay. So from this, we have solved our example 15. Now we shall go for the next problem, that is example 16. So before that, you can see, hence vector A plus vector B and vector A minus vector B are perpendicular vectors. Clear? Now let us go for example 16. So what example 16 tells? Find the projection of the vector A on the vector B. So we have to find the projection of vector A on vector B. So what will be the formula? Vector A dot B cap. That is nothing but vector A dot vector B divided by magnitude of vector B. So these things you can see from my previous videos from my YouTube channel. Clear? Where I have solved this particular formula and I have also explained the observations of projection of one vector on another vector. So let us use this formula and let us simplify. Okay, see this. Projection of vector A on vector B is given by the formula, that is vector A dot vector B divided by magnitude of vector B. So A dot B is again A1 into A2 plus B1 into B2 plus C1 into C2. So here A1 is 2, A2 is 1, B1 is 3, B2 is 2, C1 is 2, C2 is 1. So from that, 2 into 1 is 2, 3 into 2 is 6, 2 into 1 is 1. So 6 plus 2, 8 plus 2, 10. Therefore 10 divided by magnitude of B. What this magnitude of B tells? See, magnitude of B is equal to 1 square plus 2 square plus 1 square, that is root 6. Okay, so 10 by root 6, that is nothing but 5 by 3. So here this can be written as 5 by 3 root 6. Okay, so from this we can simplify that this is going to be 6 plus 2, 8 plus 2, 10, 10 by root 6. Okay, so from this, what you got here? You have got the projection of vector A on B. The projection of vector A on B. Clear? Okay. So if you don't understand the simplification of 10 root 6, you can see that you can write in the form of, see, 10 root 6. I will multiply here root 6. I will multiply here root 6. So it will be 10 by 6 into root 6. This is nothing but 3 into 5. So that will be 5 by 3 root 6. So this is your answer. 10 by root 6 you will get, but here you may get the confusion of 5 by 3 into root 6. For that, what you have to do, for 10 by root 6 you have to multiply root 6 by root 6. So 10 root 6 divided by root 6 into root 6 will be 6. So that I can simplify 5 by 3. So 5 by 3 into root 6 will be the correct answer which you have got here. Okay. I think this problem is clear. So now I will go for the next question. That is example 17. So in the example 17, you can see here, find magnitude of vector A minus vector B if two vectors, vector A and vector B, are such that magnitude of vector A equal to 2, magnitude of vector B equal to 3, and vector A dot vector B equal to 4. Okay. Then what is magnitude of vector A minus vector B? They are asking. So we know that minus B, vector A minus vector B whole square. If I do this, how can you write? You can write it as vector A minus vector B into vector A minus vector B. Clear? This is A minus B whole square. So I am writing mod of A minus B whole square as A minus B dot A minus B. So after writing this, further you can simplify the terms. Clear? Okay. See here. They have written mod of vector A minus B whole square. That can be written as vector A minus vector B dot vector A minus vector B. So from this, see here, vector A dot vector A, vector A dot vector B. See this, vector A dot vector A, vector A dot vector B minus of vector A dot vector B. Next, minus of vector B dot vector A, minus into minus, plus vector B dot vector B. Okay. So from this can be written as mod of A square. This can be written as mod of B square. And now if I make this two sum, it will be minus of 2 times of vector A dot vector B. Are you clear? So that thing they are going to write here. Mod of vector A square plus mod of vector B square minus of 2 times of vector A dot vector B. Are you clear? Okay. So that, see here, mod of vector A is 2. In the place of mod of vector A, you write 2, it will be 2 square. Mod of vector B is 3. In the place of B, you write 3, it will be 3 square. Clear? So it is going to be 9. 4 plus 9, 13. 13 minus 8 will be 5. Clear? So here, this is nothing but vector A minus vector B whole square. See this. You have simplified magnitude of vector A minus vector B whole square, that is going to be equal to 5. So now if I apply square root on both sides, it is going to be what? Apply square root here, apply square root here. It will be mod of vector A minus vector B equal to root 5. Are you clear? So it was a very simple problem. Now let us go to the next question. That is example 18. In the example 18, see what they have given. If vector A is a unit vector, that means magnitude of vector A is equal to 1. And vector x minus vector A dot vector x plus vector A is equal to 8. So this is no problem. This is in the form of A minus B into A plus B. So that you are going to have, if you simplify this, vector x dot vector x, next plus vector x dot vector A. If you simplify this two, minus of vector A dot vector x. Again if you take here, it will be minus of vector A dot vector A. So these things you are going to simplify. Clear? Okay. So magnitude of vector A is equal to 1. So you can see that vector x minus vector a dot vector x plus vector a equal to 8. These are all the given terms. This is also given term. This is also given term. Now, this I have already explained. Okay. So here you can see that vector x dot vector x is magnitude of vector x square. This two term will get cancelled. This term is minus of mod of vector a square. Because of mod of a is equal to 1, here they are going to write it as 1. It will be mod of vector x square minus 1 equal to 8. So if I take minus 1 on this side, it will be 9. If I simplify this, mod of x is going to be equal to 3, not minus 3, because magnitude is always positive. Magnitude is always positive. So for that reason, what we say, mod of x is equal to 3. So if I remove this all, see this, magnitude of x is equal to 3, as magnitude of vector is non-negative, as I already explained. Clear, students? So from this we have solved our example 18. Now let us go for example 19. Okay, very good. So here for any two vectors a and b, we always have magnitude of a dot b is lesser than or equal to magnitude of a into magnitude of b. This is called Cauchy squared inequality. That means what they are telling here, they have mod of vector a dot vector b. This should be always lesser than or equal to mod of vector a into mod of vector b. This is true. So this true statement has to be simplified. This has to be simplified now. Okay. So to simplify this, what we shall do, see here. In the inequality holds trivially for a equal to 0 or b equal to 0, because see here, if a is 0, this term will be 0. Here 0 into b will be also 0. Are you getting my point? If b is 0, this is 0. 0 into again a will be 0. So that's why on the both side you are going to have an 0 as LHS as well as 0 as RHS. For that reason, what happens? This inequality will be trivial. That proof will be trivial. So actually we are not in need of this trivial thing. So let us assume that mod of vector a is not equal to 0, and that is not equal to mod of vector b. Clear? So from this, now let us move forward. Clear? See here. What we have considered? We have considered mod of vector a is not equal to 0, and that is not equal to b. We have considered this particular thing. And we have solved this. How we have solved this? We have used the formula of a dot b. What is a dot b? Magnitude of a, magnitude of b, cos theta. Now apply mod on both sides. So already we have mod here. There will be mod for cos theta also. If you apply like this, cos theta is always lesser than or equal to 1. So by combining both of this, see here what happens. Magnitude of a minus b as it is. I will take these two terms on LHS. It will be magnitude of a into magnitude of b. So now this is going to be lesser than or equal to this particular term. That means 1. Because cos theta will remain as it is here. These two terms will come on LHS. So now what happens? If I write here what happens, in the place of 1 we will have cos theta. Here you will have equal sign. But cos theta is always lesser than or equal to 1. Mod of cos theta is always lesser than or equal to 1 because cos theta has a range of -1 to +1. If I apply mod, negative term will get cancelled. Clear? So mod of cos theta is lesser than or equal to 1. That's why in the place of this mod cos theta I will write 1. So therefore what you are going to have, mod of a dot b is lesser than or equal to mod of a into mod of b you are going to have. So this is the required answer. Clear, students? So this is how we are going to simplify this particular problem number 19. I think you are very much clear with this. So I will remove all the rough work. Now I will go for question number 20. So for question number 20, what they are asking to prove for you? See, for any two vectors, vector A and vector B, we always have magnitude of A plus B is lesser than or equal to magnitude of A plus magnitude of B. This is the diagram. Clear? Triangular addition. They are using triangular. They are using triangular addition. They are using triangular addition. So that's why here let us solve this particular problem. So again it is same. If A equal to 0, B equal to 0, this is a very trivial case. So that's why what we shall consider, mod of A is not equal to 0, mod of B is not equal to 0. Then say this, a very simple thing. If I make square of this, what you are going to write? Vector A plus vector B dot vector A plus vector B. You are going to write like this. If you simplify this, it will be vector A dot vector B plus vector A dot vector A plus vector A dot vector B plus vector B dot vector A plus vector B dot vector B. Clear? So this is magnitude of A square plus 2 times of A dot B plus mod of B square. Clear? So from this we can see that what I have simplified. Okay. We got mod of vector A square plus mod of vector B square plus 2 times of vector A dot vector B. So now if I apply mod to these terms, it will be lesser than or equal to. This sign will change as lesser than or equal to. Clear? So it will be lesser than or equal to mod of A square plus 2 times of mod of A mod of B plus mod of B square. Okay, you can see here. See this. Equal sign changes to inequality and this will become mod. Okay. So now I can write this term as magnitude of A plus magnitude of B whole square, because you know this formula. Clear? Say this. Okay. After this, what we have proved, magnitude of A plus B whole square is lesser than or equal to mod of vector A plus mod of vector B whole square we have proved. Clear? This is already proved statement. So if I apply square root on both sides, what happens? Magnitude of A plus B will be lesser than or equal to magnitude of A plus magnitude of B. Clear? So this thing was in need. That means we have to prove this. So after this step, apply square root on both sides so that you are going to have this required result. Clear, students? Okay. I think the problem 20 is also very much clear. Now I will go to the next. See this remark, very important regarding your question number 20. If the inequality holds in triangular inequality in the above example 20, that is mod of A plus B is equal to mod of vector A plus mod of B, then magnitude of vector AC equal to magnitude of vector AB plus magnitude of vector BC, showing that A, B, C are collinear point. Collinear point. That means from this remark what we understand, whenever you want to prove collinear, you have one of the technique to show that you have to show vector AC must be equal to vector AB plus vector BC, because collinear means if this is the line, this is point A, this is point B, this is point C. All the 3 points are on the same line. All the 3 points are on the same line. That's why the points ABC are called collinear points. That's why ABC are called collinear points. So now the length of AC must be equal to the length of AB plus the length of BC. If I add the length of AB plus the length of BC, it must be equal to the length of AC. Are you clear? That's what they are telling here. Because if triangular inequality holds, see that triangular inequality in the previous case. What is triangular inequality? Vector AC is lesser than or equal to vector AB plus vector BC. See this, magnitude of vector AC is lesser than or equal to magnitude of vector AB plus magnitude of vector BC. Here what we have shown that mod of vector A plus B is lesser than or equal to mod of A plus mod of B. This we have shown, this we have proved. So this is nothing but magnitude of AC, this is nothing but magnitude of AB, this is nothing but magnitude of BC. Clear? So now if this inequality becomes equal, if this inequality, see here, if this inequality becomes equal, what they say here, the point A, the point B and the point C must be on the same line. When see this equal, when that is vector AC is equal to vector AB plus vector BC. So if this happens, this point C will be here and it will be on the same line where A and B are present. Therefore, vector AB plus vector BC is going to be equal to vector AC. This is point C. Okay. I think the remark is also very much clear to you all. So please remember, if you want to show point A, point B and point C as collinear, the length of AB, the length of BC must be equal to the length of AC. This is length of AC. This is length of AB. This is length of BC. Clear? So all the points lie on the same line. Therefore, 3 points ABC are collinear. So very important, because on this the problems are going to be asked in your board exams. So for that, please remember this remark. Are you clear? Okay. Now let us go for the problem on collinear. See, they have given the 3 points. Show that the points A, B, C are collinear. We have to prove the collinear. That means what we have to prove? Magnitude of AC is equal to magnitude of AB plus magnitude of BC. Clear? This thing we have to prove. So please remember this. So first find vector AB, vector BC, vector AC. They have given A. This is position vector. Position vector means vector OA. Here B, point B means it is position vector OB. This is position vector OC. So if you want to find AB, vector AB is equal to what? Please remember the formula, that is vector OB minus vector OA. Vector OB minus vector OA. Clear? So this is OB vector, this is OA vector. You have to subtract. See here, coefficient is 1. 1 minus of this minus will be what? Plus. You have two vectors. First one is OB, I cap plus 2j cap plus 3k cap. this has to be subtracted with minus 2i cap plus 3j cap plus 5k cap. Clear? So if you solve this, minus into minus will be what? Plus. Minus into plus will be what? Minus. Minus into plus will be what? Minus. Clear? So here you have 1. Minus into minus is plus 2. Here you have plus 2. Minus into plus will be minus. So plus 2 minus 3. Plus 2 minus 3. This is plus 3. Minus into plus will be minus. Plus 3 minus 5. Plus 3 minus 5. So this is 3 minus 1 minus 2. So 3i cap minus j cap minus 2k cap. Clear? On the same way, we have to solve the next things. Here BC means this is nothing but vector OC minus vector OB. So OC is 7i cap minus k cap. OB is I cap plus 2j cap plus 3k cap. Here you have 7. So 7 you have to subtract minus, here you have 1. So you will have 7 minus 1. Here you don't have k cap, that will be 0. Sorry, j cap, that will be 0 minus 2. Here you have minus 1. Here you have plus 3. Minus into plus will be minus. Minus 1 minus 3. See here. 7 minus 1, 0 minus 2, minus 1, minus 3. So further you simplify those things. You will have plus 3 minus 1 minus 2. 6 minus 2 minus 4. So further you simplify the third one, you will get. So now, what is magnitude of AC? Magnitude of AC is equal to square root of 9 square 81 minus 3 square 9 minus 6 square 36. So it is 90. 90 plus 36, it will be 126. Okay. Next, magnitude of BC also same. 6 square is 36 plus 2 square is 4 plus 4 square is 16. This is magnitude of BC. Next, magnitude of AB. It will be 9 plus 1 plus 4. So this is 14 and this is 20, that is root 56. Clear? Okay. See this. AB root 14. See here. Square root of 9 plus 1 plus 4. This is root 14. Next, BC. This is 36 plus 4, 40. 40 plus 4. 40 plus 16. That is 56. This is root 14. So 56 can be written as 2 root 14. Clear? So now square root of 9 square is 81 plus 9 plus 36, 90. 90 plus 36 is root 126. That is nothing but 3 root 14. 3 root 14, because you can write it as 9 into 14. Check this, 9 into 14, it will be 126. That is nothing but 3 root 14. So now if you take magnitude of AB plus magnitude of BC, that is root 14 plus 2 root 14 will be equal to 3 root 14. Therefore, magnitude of AC is equal to magnitude of AB plus magnitude of BC. That is our required result. Hence, ABC are collinear points. Clear? Okay.